Welcome to the Student the Brand. This is your Shiva sir. Today we are going to discuss about projectile motion, grade 11, CBSE. So very important topic. Very important topic we are going to discuss. Projectile motion. Okay. So ready everyone. So normally, we are dropping the object, or the object is moving along x-axis. So that we can say one-dimensional motion. Here we are discussing object moves with the two-dimensional, that is along x-axis and y-axis. So the two-dimensional I'm considering. Okay. Object moves in two-dimensional motion. That is projectile motion. Today we are going to discuss about projectile motion. Projectile motion. Okay, here. So in the previous case we discussed in the previous videos, if you see, related to grade 11, units and measurement, vectors and scalars. After that, motion in a straight line. Next one, motion in a plane. So in that we are talking about projectile motion. Motion in a straight line. So object moves in one-dimensional motion. Okay, object moves along x-axis. If I say, that is called one-dimensional motion. Okay, so we know equation of motions. V equal to U plus AT, S equal to UT plus half AT square, V square minus U square equal to 2AS. So we know all those equations, right? We will use those equations, okay, to get the formula of trajectory of the projectile. Okay, now we will see. And projectile motion, so we are throwing object, we are projecting with certain angle with the x-axis or with the ground, that obliquely. So we are throwing the object, we are projecting the object obliquely, means with certain angle with the ground. Okay, and a certain height also, from certain height also if you throw the object, that also projectile motion. And an inclined plane, so up the plane and down the plane also we can take. Now today exclusively we'll discuss about oblique projectile. Okay, that is projecting the particle along. So I'm taking like this. This is x-axis and y-axis. I'm taking this y-axis. X-axis and y-axis. I'm throwing the particle like this with certain angle. Okay, so this is the initial velocity of the particle. Initial velocity of the particle, that is u. So it is making some angle alpha. I'm taking. You can take theta also. We can take theta also. I'm taking certain angle alpha. Okay, so we have to resolve the components. That also I did. Based on that also I did one video resolving the components of vectors. So I'm taking here. So scalars and vectors, I resolve the components. So this initial velocity, I'm taking this alpha. This is x-axis and y-axis. So in the alpha case, so we can take theta also. That is your choice. If you take theta also, fine. So you can take it. No problem. Now you can consider here. Okay. Now see here. Now what is the cos alpha? Cos alpha. Cos alpha equal to adjacent side by hypotenuse. Adjacent side is x. Hypotenuse is u. And x equal to u cos alpha. U cos alpha. And sine alpha equal to what is the formula? Opposite side by hypotenuse. Opposite side is y and the hypotenuse is u, and y equal to u sine alpha. Okay, so now you can see here x equal to u cos alpha and y equal to u sine alpha, right? Yes. Along x-axis and y-axis. Along x-axis and y-axis. And here we can also take ux because velocity, initial velocity along x-axis. Initial velocity along y-axis. So there is a component. Initial velocity u along x-axis, that is a velocity component ux, and y-axis uy I am taking. And here we know orthogonal vectors along x-axis, y-axis and z-axis. That if you take unit vectors, if you are considering unit vectors also, along x-axis unit vector is I cap, along y-axis unit vector is j cap. Along x-axis, listen carefully, very very important. Along x-axis unit vector is I cap. Along y-axis unit vector is j cap. So about unit vector already discussed. About unit vectors. Suppose I am taking unit vectors. Suppose a bar equal to 2 I cap plus 3j cap if you are taking. So unit vector how we can a cap equal to a bar by mod a bar. So mod a bar means magnitude of a. So that is nothing but a. That is nothing but root over 2 square plus 3 square. That is nothing but root over 4 plus 9. So root over 13 I am taking. Now a cap we can write a cap equal to a bar. A bar is nothing but what is a bar? 2i cap plus 3j cap by so root over 13. Yes or no? Like this we can identify the unit vector. Normally unit vector magnitude is 1. So I cap, j cap, k cap, whatever I am considering I cap. So j cap and k cap unit vector magnitude is 1. Okay. So fine. So along x-axis, y-axis, z-axis I am taking. Along x-axis I cap is a unit vector. Along y-axis j cap is a unit vector. So along z-axis k cap is a unit vector. Okay. So now we derived along x-axis. If you are dividing your initial velocity along x-axis ux, initial velocity along y-axis uy. Okay. So this is a projectile. So we are projecting with certain angle. Okay. Right. Now x, y, alpha, u. Cos alpha equal to x by u. So adjacent side by hypotenuse. So if you are taking x equal to u cos alpha, sin alpha equal to y by u. That is nothing but y equal to u sin alpha. Now how can we write vector u? So that is u if you are taking u. Okay, sin alpha, u cos alpha I cap plus u sin alpha j cap. Yes or no? Along x-axis and along y-axis we are considering. Along x-axis u cos alpha I cap because unit vector also there, right? Along y-axis u sin alpha j cap. So if you are taking here, Okay, if you're resolving the components into two parts, along x-axis, along y-axis, u I'm taking, alpha I'm considering, u cos alpha, okay, so I cap, and here u sin alpha, j cap, u sin alpha, j cap. Okay, so u bar you can take u cos alpha I cap, u sin alpha, j cap. Now, we know final velocity v equal to u plus at, u plus at. Here, along x-axis, ax if you are taking along x-axis, horizontal velocity u cos alpha is same. U cos alpha is same. At final velocity vy is 0. Vy is 0. So at final velocity, and ax is also 0, and ay equal to minus g j cap. So vertical, so acceleration along y-axis, ay equal to minus gj, because so actually acceleration due to gravity always it acts downward direction, right? Always acceleration due to gravity acting downward direction. But along y-axis, the object, if the object is moving along y-axis, acceleration due to gravity along y-axis minus g, because it is moving opposite to the acceleration due to gravity, right? That's why ay equal to minus g. Ay equal to minus g. Okay, so this if you are taking velocity and s equal to ut plus half at square, s equal to ut plus half at square. Okay, so here we can take initial velocity. So velocity at any time, velocity, so final velocity at any time if you're taking, and velocity at any time, and displacement at any time if you're taking certain time. Then so v equal to initial velocity is u cos alpha, I cap, and plus u sin alpha, j cap. Okay, so minus g j cap and t. So initial velocity v equal to, so u cos alpha I cap, make it. So here we can take j cap common. So u sin alpha, j cap, u sin alpha minus g t j cap. Okay, so like this we can take. So s equal to ut plus half at square. S equal to ut plus half at square formula if you are taking. S equal to, so initial velocity u cos alpha, I cap plus u sin alpha j cap, okay, and t plus half into minus g j cap t square. Okay, so t square is that formula. Now if you are separating j cap, then you will get s equal to ut cos alpha plus j cap ut sin alpha minus gt square. So like that we will get it. I hope it is very clear. Check once. Very important concept. Very important concept. So if you are throwing the particle, if you are projecting the particle, so making some angle with the x-axis, that is alpha. Okay, at any time. So what is the final velocity? So at any time. So certain time I am taking here. Okay, so v equal to u cos alpha I cap plus u sin alpha j cap minus g, so j cap into t, and s equal to ut plus half at square. So displacement if you are taking s equal to ut plus half at square. If you are substituting the values, you will get it this one. Yes or no? Check once. Right? Now path of the projectile is a parabola. Is it true or false? We'll check now. Path of the projectile is a parabola or not? So we will check. So the trajectory of a projectile is a parabola. Okay, trajectory means what path it is followed. So the path. So this is the path, that is called trajectory of a projectile. So we are projecting, right? So that is a particle, right? Okay, so now we will see that. Okay, chalo then. So very important, listen carefully here. Now, so we know S equal to ut plus half at square. S equal to ut plus half at square. We know this one. We know this formula, right? Okay. Now, along x actually, so all these equations, so before that, I will give the equations, all the equations. Those are, so I'm taking along x-axis I cap, I'm taking here. Along x-axis I cap. Now, we know the formulas. What are those? V equal to u plus at, first equation. Coming to the second equation, S equal to ut plus half at square. S equal to ut plus half at square. Third equation is v square minus c square equal to 2as. So these three equations, if you are writing along x-axis and y-axis, these three equations, along x-axis and y-axis you have to write. Okay, how we have to write along x-axis and y-axis? So x-axis, that is called horizontal component. X-axis is a horizontal component. X-axis is the horizontal component. X-axis, that is called horizontal component. Horizontal component. Horizontal component. Okay, now that is Vx equal to ux plus ax into t. Second one, Sx equal to ux t plus of ax into t square. Anyway, time is same. So any system, so time is same. So no changes in time. Then Vx whole square minus ux whole square equal to 2ax and sx. Now coming to the vertical component along y-axis, sir, it is, so these are very simple only, right? Why you are writing? So while you are taking into the formulas along x-axis and y-axis, you have to imagine, if you are taking horizontal component, you have to think about only horizontal component along x-axis and y-axis, then their conditions. Coming to y-axis, that is vertical component. You have to consider vertical component. Y-axis I am taking vertical component. Okay, along vertical component, that is, so if you are taking, so v y equal to uy plus ay into t. Okay, so sy equal to uy into t plus half into ay into t square. Then vy whole square minus uy whole square equal to 2ay and sy. Okay, so this is about along x-axis and y-axis. The components, okay, x-axis is the horizontal component, y-axis is the vertical component. Okay, so listen, observe carefully. X-axis along horizontal component, y-axis along vertical component, and the formulas, very important formulas you have to follow. Okay, so if you are taking along x-axis, you have to think about x-axis itself. If you are taking formula along y-axis, you have to think about y-axis. Okay, conditions you have to write first before applying, before writing, before substituting in formulas. So in equation, you must take the conditions. You have to take the conditions. After taking conditions only, you have to substitute in equation, then you will get proper values. Okay, right. Then I hope is it clear. Okay, done. Come to the next one. Very important equation. So trajectory of a projectile. Trajectory of a projectile means the path of the projectile. Trajectory means in which path it is followed. That is called particle, projectile. Okay. So we have to identify. Normally we know the formula S equal to ut plus half at square. Yes or no? S equal to trajectory of a projectile. Trajectory of a projectile. Trajectory of a projectile. Okay, so let's start. Projectile. Now S equal to ut plus half at square. S equal to ut plus half at square. Okay, so conditions. U x equal to u cos alpha. Very important conditions. So you have to substitute these conditions. Uy equal to u sin alpha. Ax equal to 0, ay equal to minus g. So very important. So make sure that you are anyway t, so no problem, t is same only. Okay, now so here along x-axis if you are taking, so x-axis equal to along x-axis and along y-axis if you are taking y. Okay, so these conditions are very important. These conditions are very important. So make sure that you are following these conditions. Now along x-axis I am taking x-axis. Along x-axis if you are taking x equal to same equation along x-axis. X equal to ux into t plus half into ax into t square. So x equal to ux is nothing but u cos alpha into t. Anyway ax becomes 0, this entire term becomes 0. This entire term is 0. Yes or no? This entire terms become 0 because ax is 0, right? Ax is 0, so that's why this entire terms becomes 0. This entire terms become 0. Then t equal to x by u cos alpha. So equation 1. Okay, so this one you can take it as equation 1. Okay, next one along y-axis. Along y-axis I am taking along y-axis. So that is same formula s equal to ut plus half at square I am writing. S equal to ut plus half at square. Along y-axis you have to write. Along y-axis. Okay. So right. So here y equal to uy into t plus half into ay into t square. So see the conditions. Y equal to uy is, what is the formula? Uy equal to u sin alpha. So t let it be plus half into ay is nothing but minus g t square. So in first equation, what is the t value? T equal to x by u cos alpha. So from first equation number 1, so you can take it as equation 2, substitute. So equation 1 in equation 2. Okay, substitute equation 1 in equation 2. Okay, substitute equation 1 in equation 2. Then y equal to u sin alpha. What is the t value? X by u cos alpha. Plus half into minus g into t square. T square is nothing but x by u cos alpha, u cos alpha whole square. Yes or no? X by u cos alpha whole square. Very, very important. Very, very important. Okay. So x by u cos alpha whole square. X by u cos alpha whole square. Right? Now, how you will get the final equation? So check once here. Once again, I'll explain. Listen carefully here. Okay. Trajectory of a projectile. Trajectory of a projectile. Okay, path of the projectile. So path we are finding. So we know s equal to ut plus half a t square. Along x-axis we are taking, along x-axis. So conditions, I already wrote the conditions. We have to follow these conditions. These conditions are very, very important. These conditions are very, very important. Along x-axis u cos alpha, along y-axis u sin alpha. So that's why I said before I wrote the equations, along x-axis you have to take this equation. Along y-axis you have to take these equations. So after taking, you have to take the conditions. Conditions are very important. So those conditions you have to substitute in the equation. You have to substitute in the equation. Yes or no? Check once. Ux equal to u cos alpha, uy equal to u sin alpha, ax equal to 0. Why? U cos alpha is same. Throughout the path, U cos alpha is same. Along x-axis, U cos alpha is same. Initial velocity is same. That's why. So Ux equal to U cos alpha. That is so velocity is same. The automatically acceleration along y-axis, along x-axis 0, right? Along y-axis acceleration due to gravity is there. So Ay equal to G. Okay, minus G. So now, anyway, x-axis, along x-axis, along y-axis. Okay, now you can take here x equal to, so we are taking along x-axis, x equal to uxt of ax t square. Here, ux equal to u cos alpha, ax equal to 0 anyway. So t equal to, from this equation, t equal to, so x by u cos alpha, equation 1. Coming to y-axis. Along y-axis if you are taking s equal to ut plus half a t square, y equal to uyt into half ay into t square. Now y equal to, so uy is u sin alpha, into t plus half ay equal to minus g t square. And y equal to u sin alpha. Here from equation 1, that's the reason, so I mentioned equation 1. So equation 1 you are taking. So equation 1, x by u cos alpha plus 1 by 2 minus g x by u cos alpha. Same equation we are substituting in the place of t. In the place of t we are substituting equation 1. Okay. So I hope it is very clear. Yes or no? Then now final equation, we'll get final equation. Check once here. So what is the final equation? So here we can cancel it, right? U get cancelled. So U get cancelled, and that's enough. So sin alpha by cos alpha equal to tan alpha. So y equal to tan alpha into x minus of gx square by u square cos square alpha. Now, so we can take final equation. So y equal to x tan alpha minus gx square by 2u square cos square alpha. That is the final formula. 2u square cos square alpha. Okay, so I'll write here. So just check it once. Final equation. Y equal to x tan alpha minus, so gx square by 2u square cos square alpha. That is the final equation. So very, very important equation. Okay, I will write here itself. So if you want to, I will write here final equation. So no need to get confused. That's why I'm taking here itself. Tan alpha minus of, So we can take directly gx square by gx square. Gx square by 2u square cos square alpha. So this is the final equation. Okay, so continuation will be there. That's why I wrote here. Okay, so you can rub here. Anyway, it is not seen, so we can't able to see this, right, because small letters. Okay, so now you can see here. This is the final equation. Yes or no? Y equal to x tan alpha minus gx square by 2u square cos square alpha. Is it clear or not? Check once. Follow the stepwise. Okay, so you have to follow one by one. So one by one, if you follow, then you'll get the equation. So if you miss any one of this step, then you won't get it. So you have to follow step by step. Carefully, one by one. So trajectory of a projectile. First you have to write the conditions. These conditions are very important. First write the conditions. If you write the condition, just you have to substitute those conditions in this equation. Only one equation. S equal to ut plus half at square. If you take this equation, if you substitute this condition, that's enough. So automatically you'll get the equation. You don't need to worry about it. Sir, why sir this much big lengthy equation? So how can we remember? You don't need to remember. Just to follow these conditions. One equation. That's enough. Automatically one by one you will get it. Okay, so you have to solve one by one. That's enough. Simple. So only remember these conditions. Take this equation, substitute those conditions along x-axis, along y-axis, and substitute equation 1 in equation 2. That's enough. So anyway, you know that, right? Process. Simplifying the process. That's enough. You will get it. Yes or no? Is it clear? So if you have any doubts, let me know. If you have any doubts, you can ask. Now next one, time of flight, maximum height. Next, time of flight, maximum height and range. Height, that is height we will discuss. Actually height only, that is where we'll get maximum height means here only, and range. Range is nothing but from starting of the point of projection it reaches the ground. Until that point is called, that is range. Okay, so this one is range from here to here, that is called range. Range R. This one is the range, and this one is the height. Okay, so we'll find out next. So this side range. So they here only will get maximum height, and depending on the angle. So how much angle it is? Okay, we will see. Is it clear? Shall we? Time of flight and okay then. Chalo. We'll start. So I given my Instagram ID. Those who have any doubts related to doubts, concerns, if you have any discussions, you can contact to me through Instagram page. So you can follow the Instagram. Okay, so I already given the link in the description. Check once. Okay, check once. Done. Now, so by seeing this one, the trajectory of projectile is a parabola. Right? So time of flight we will discuss. Time of flight now. Time of flight, very very important. Today we will discuss 3 points. Point number 1, time of flight, height and range. Formulas every time after deriving I'll write here. Okay, so time of flight and height, that's the maximum height, and range also will discuss. Range. Now, time taken by the body to fly in air. Okay, so from point of projection to until it reaches the ground. From point of projection to until it reaches the ground. So the object is flying in the air. So that is called time of flight. Time of flight. So object is moving upward direction. That's why we can take, so S equal to ut plus half at square can we take? S equal to ut plus half at square. Yes or no? S equal to ut plus half at square. Along y-axis, so y equal to uy into t plus half into ay into t square. Here conditions are very very important. So keep in mind, conditions are very very important. So Sy equal to 0. Why? Because, so when you project the particle along y-axis only, you have to think, as I said in the previous case, when you are taking along y-axis, you have to think only in the y-axis. If you are thinking x-axis, you have to think only in the x-axis. So you have to follow. X-axis means x-axis. Y-axis means y-axis. That's enough. Okay, so equations also, while you are substituting the conditions also, you must follow. If you are taking x-axis, only x-axis. If you are taking y-axis, only y-axis. So along y-axis, I am throwing the particle, again it reached to the, to the ground. Okay, so ground, that's enough. Along y-axis it is 0. Displacement is 0, right? Displacement is 0, so that's why 0. And uy equal to u sine alpha. So as I said, alpha equal to theta, so you can take here theta also, fine, no problem. Okay, so I am taking alpha. Right now, ay equal to minus g. Anyway, t is t only, no changes. Time will not change. Time will be same only. Okay, so take it, time. Right now, so substitute these conditions in the equation. Substitute these conditions. These are the conditions. When the body is moving vertical motion along y-axis, so these are the conditions. Only in this case. So now you can take, so 0 equal to uy is nothing but u sine alpha t plus half into, so ay is nothing but minus g and t square. So you can take one term this side. So gt square by 2 equal to u sine alpha into t. So we can cancel t. Okay, so t get cancelled. So what is the remaining? So t equal to 2u sine alpha by g. 2u sine alpha by g. That's the time of flight, right? So we can take capital T. Capital T we can take. So that is capital T equal to. So here I am writing 2u sine alpha by g. Okay, so I am writing all the equations here itself. I am writing all the equations here. One second. Is it clear? Once again I will explain. Listen carefully. Once again, listen carefully. Along y-axis, so time taken by the particle to fly in the air. So from here to here, from point of projection until it reaches the ground. Okay, projectile reaches the ground. Okay, so this total time is called time of flight. So S equal to ut plus half at square, Sy uy t plus half ay into t. So Sy is nothing but elevate along vertical direction. As I said, along vertical direction, Sy is 0. Uy equal to u sine alpha. So on t and ay equal to minus g. As I said, acceleration due to gravity, it is moving. So opposite acceleration due to gravity, that's why ay equal to minus g. So 0 equal to u sin alpha t plus half into minus g t square. Here you can take this entire term to this side, gt square by 2. So tt get cancelled. So t equal to 2u. So you can cross multiply 2u sin alpha by g. Okay, so that is only time of flight, t equal to capital T 2u sin alpha by g. 2u sin alpha by g. So time of ascent plus time of descent. Time of ascent is u sin alpha by g. So u sin alpha by g. So time of ascent is to u sin alpha by g. Time of descent is u sin alpha by g. So time of flight is nothing but time of ascent plus time of descent. What is time of ascent? What is the time of descent? Time of ascent is nothing but time taken by the body to reach the maximum point. So this is the maximum point. So until here, this is called time of ascent. And the time of descent is from maximum to the ground. Maximum to the ground. So from maximum point to the ground, that is called time of descent. So time of flight. So time of ascent plus time of descent. That is called time of flight. Okay. So time of flight formula is t equal to 2u sin alpha by 2u sin alpha by g. I hope it is very clear. Is it clear? Is it clear? Right. Now, next. So, maximum height we will discuss. Maximum height. Normally height. So, that is only. So, maximum height depends on the angle I said, right? Height if you are taking. There is maximum height and maximum range. So, now Vy square equal to Uy square. So V square minus C square equal to 2s plus 2a y into h. Oh, so S is nothing but h. S is nothing but h. So this is nothing but h here. Yes. S is nothing but, so I am writing here S equal to h and ay equal to minus g and v equal to 0, Vy equal to 0, final velocity when it is reaching to the maximum point, Vy is 0. So Vy is 0, so you can take here. And Uy equal to, so what is Uy? U sin alpha. U sin alpha, right? Now substitute these points. These are the conditions. These conditions you can substitute in the equation. If you substitute in the equation, so 0 equal to u sin alpha whole square, okay, plus 2 into minus g into h. Now 0 equal to u square sin square alpha minus 2gh. So you can take this entire term this side. 2gh equal to u square sin square alpha. Then h equal to u square sin square alpha by g, 2g. Yes or no? Check once here. So any doubts? I already said these conditions are very, very important. Even though you are taking equation, if you are not substituting the conditions properly, you won't get it. So you won't get a proper equation. So you must follow the conditions. What are the conditions are given in the case, particular case, so in which case we are considering. So maximum height. So at this point we are taking, right? So check once. Is it clear or not? Understood or not? Now, so range we will take. So now I'll write h equal to height, h equal to u square sin square alpha by 2g. Okay. If you substitute alpha equal to 45, you'll get maximum height and maximum range. Range I will explain once again. Still we didn't discuss range. So I will explain the range. So range, that is S equal to ut plus half at square. Range is nothing but horizontal displacement. So from starting to until ending. So where it reaches, point of projection to until it reaches the ground. So that is a range. So here along x-axis I am taking. So along x-axis I am taking. Okay, so of x. So now write the conditions. After writing equation and along x-axis you are taking, along y-axis you are considering, you have to think. Along x-axis. So along x-axis you have to write this equation. If you write this equation, so almost you are fixed with that. Okay, so you are fixed in mind. So along x-axis I have to think. Along x-axis I have to think. So along x-axis you are considering. So this is a horizontal component, that is nothing but I am taking range. R I am considering directly. R. So first we will write the conditions, I said, right? Conditions. So ux equal to u cos alpha and t anyway same. So ax equal to 0 anyway acceleration along x-axis and sx equal to r range I am taking. So that's enough. So these conditions if you apply, that's enough, you'll get it. So here time is nothing but time of flight. Okay, so it reaches from here to here. So time how much it is take? So how much we have to take? Time of flight only. Time of flight formula. What is the time of flight formula? Here I wrote 2u sin alpha by g. That also you have to write 2u sin alpha by g. 2u 2u sin alpha by g. 2u sin alpha by g. Right? Now substitute the values. So r equal to u cos alpha and time of flight is 2u sin alpha by g. Anyway, this whole terms become 0 because ax is 0, right? So acceleration along x-axis 0. So this whole term becomes 0. Then only these terms only, r equal to u cos alpha 2u sin alpha by g. Yes or no? Now you can take r equal to here u into u square. So u square. So 2 into sin alpha into cos alpha by g. So 2 sin alpha cos alpha we can write sin 2 alpha. Okay, that is r equal to u square sin 2 alpha by g. Okay, so this is the equation. Now tell me. So r equal to, what is the formula? U square sin 2 alpha by g. Is it clear? Do you have any doubts? Again I will explain. Don't worry about it. I will explain. So I am taking the range. This is the range from point of projection to until it reaches the ground. Okay, so s equal to ut plus half at square. Along x-axis I am taking. So s equal to ux into t plus half into x t square. So this is the range. So that's why I am substituting r. Ux equal to u cos alpha initial velocity and ax equal to 0 because acceleration along x-axis 0. And see how much time it is taken to fly in the air, that is time of flight. So t equal to u sin alpha by g. R equal to u cos alpha. So u cos alpha into t is 2u sin alpha by g. So this whole term becomes 0. Then r equal to, so u into u square, 2 into sin alpha into cos alpha by g. Then sin 2 sin alpha cos alpha is sin 2 alpha. So sin 2 alpha by g. So r equal to u square sin 2 alpha by g. So these are the equations what we got till now after solving. So we got these equations. Okay, those are time of flight. Time of flight t equal to u sine alpha by g. Height u square sine alpha by 2g. Yeah, range u square sine 2 alpha by g. So maximum height if you are substituting alpha equal to 45. So can anybody say, okay, you can send in Instagram, okay, you can type. So what is the answer? You will get it if you substitute alpha equal to 45. Okay, so this is about projectile motion. Okay, so projectile motion, everything along, okay, along x-axis, y-axis, resolving the components, time of flight and height, range, everything we discussed. Okay, so thank you so much for joining and attending and listening the class. So if you like the video, if you like the content, like my explanation, so do like, share and subscribe to Student Brand. This is your Siva sir from Student Brand. Thank you so much. Okay, so if you like the content, again I'm asking, so please do like, share and subscribe to Student Brand. Thank you so much. We'll see you in the next class. Thank you.